Good morning all of you. Welcome to Amrita IAS Academy. We are resuming the program Learn CSAT through PYQ Series with another topic called Permutation and Combination. While analyzing the previous year questions from the year 2014 to 2021, there are around 15 questions I've asked from the particular topic Permutation and Combination. Oftentimes, students complain that the topic is a bit dry and tough. Let me say that the topic is very simple if you understand the basic idea of the topic permutation and combination. There are certain basic tricks and basic idea regarding the topic so that one can solve all the questions from the particular topic. So let us start the program. Once again, welcome to Amrita IAS Academy. Let me begin by explaining what the concept permutation and combination is. See, permutation relates to the act of arranging all the members of a set into some sequence or order. So permutation implies is a kind of arrangement. For example, if there are 5 persons, 1, 2, 3, 4, 5, if there are 5 persons, these 5 persons can be arranged. These 5 persons can be arranged in different patterns or different scenarios. These 5 in the first case, this first person occupying the first position, second person in the second position, and so on. And we can change the order of the arrangement in a different manner. Like, let's say the second person occupying the first position, third person occupying the second position, first person occupying the third position, fifth person occupying the fourth position, and fourth person occupying the last position. So we can rearrange the positions of occupancy of these 5 persons. So this is what actually the idea of permutation is. Permutation implies the possible number of arrangements, of all the members. For example, let me say another example. Let us assume that an Indian cricket team, and every cricket team contains 11 players, right? Okay, and every cricket team contains 11 players. Indian cricket team for a match against Sri Lanka contain 11 players, team 11, and Rohit Sharma as the captain, and KL Rahul as a vice captain, and there are 9 other members. Totally there are 11 members in the team. Okay, so this is a set of peoples, and when you are going for batting, there will be an arranged order of preference, that is who is going to bat first, or which 2 persons are bat first, and who is going 1 down, who is batting second down. So there is an order of preference, and we have to arrange these 11 peoples in different manner. This is what actually the permutation is. It's a set of persons, and we are arranging these persons in different manners. And permutation implies the maximum number or the possible number of arrangements of this available number of persons. Clear? I hope you what actually the idea of permutation is. So permutation, as the definition implies, it's related to the act of arranging all the members of a set into some sequence or order. Clear? Okay. A permutation is a choice of R things from a set of N things without replacement and where the order matters. Which means, if there are total N persons are there are a set of N things, which means there are N number of persons or N objects, whatever, N things, and out of these N things, we are preferring R persons or R things. Total there are N things, and out of these N things, we are preferring R things. And the number of possible arrangements of these R things out of the total N things can be written as NPR. This NPR, if there are total N number of persons or N number of things, and out of this N number of things we are selecting R number of things, then the possible number of arrangements can be expressed as NPR. the NPR will be n factorial divided by n minus r factorial. The logic behind this expression will be detailed in the next slide. Okay, for the time's sake, please understand that the expression for NPR, which means we are choosing or we are taking r number of persons out of the total n number of, or r number of things out of the total n number of things, and the number of possible arrangements of these r things out of the total n things can be written expressed as NPR, and this NPR is equal to n factorial divided by n minus r factorial. Okay, fine. The next idea is, or the next concept is combination. So the topic is permutation and combination. So we have already explained what actually the idea of permutation is. Now we are going to discuss or going to express what the idea of combination. See, combination is a way of selecting items from a collection such that the order of selection does not matter. See, in case of permutation, their order is actually matters. Who is going to bat first? Who is going to bat second? Who is going to bat third? So actually we are concerned or bothered about their place of occupancy, or where they should bat, at what position they should bat first, whether it is at the first position or second position, third position, etc. And we are calculating, or we are taking the maximum possible number of combination which is possible out of the total set. So in case of permutation, what actually matter is their positions or occupancy. However, in case of combination, what actually the idea of combination is selecting certain items. We are actually selecting certain items. In permutation, already selected items are arranged. In combination, we are actually selecting. In permutation, there are already 11 members in a team which are already selected, and what we have left is, what we have to do further is to arrange these persons in a definite order from 1 to 11. Who is going to bat first, second, third, etc. up to the last man. Clear? Okay. However, in case of selection, we have to select these 11 members out of a large number of persons. So in case of combination, we actually bothered about selecting certain number of items from a collection. But the selection does not matter what the order of selection doesn't matter. We have to pick 11 members. We do not want to bother about their relative positions or their arrangements, etc. So in case of combination, we are concerned about selection. In case of permutation, we are concerned about the arrangement of the selected members. Clear? Okay. If there are total set n or n numbers, the set contain total n elements. Out of these n elements, we are actually selecting r number. Total there are n number of players, and we are actually selecting just r numbers or r number of players. Then the combination can be expressed as NCR, and the expression for NCR or the equation for NCR is equal to n factorial divided by n minus r factorial into r factorial. So this is a basic idea. I hope many of you have already learned this particular topic for other competitive exams or in your school times, etc. Okay. However, for a beginning, let me explain what I have explained what actually the idea of permutation and combination and their expression. So the expression for permutation NPR is equal to n factorial divided by n minus r factorial. The expression for combination NCR is equal to n factorial divided by r factorial into n minus r factorial. Clear? Okay. One more expression for quick solving questions. NC1 will be equal to n and NCn equal to 1. What actually the idea of NC1 is? See, what actually the NC1, what actually NC1 implies? NC1 implies there are actually n number of persons, right? Or there are n number of elements in a particular set. What is the 1 implies? 1 implies that out of the set of n elements, we have to pick one person or one element. What is the maximum possible number of selecting that one element out of the total n element? See, we can select the first one. There is a possibility. We can select the second. Out of the total n number of elements, we have to choose only one element. Am I right? Yes. So we can we can select the first person or first element. We can select the second element. We can select the third element, and we can select any of these members. So the maximum possible number of selection will be 1 plus 1 plus 1 plus 1 plus 1 plus up to n. What is the possible number of selection? Possible number of selecting one person out of n persons, or one element out of n element? It is definitely n. That is why nc1 is equal to n. Clear? Okay. Next we have to consider the idea of NCN. NCN what implies? There are total n number of elements. Out of the n number of elements, we have to select n number of elements. Total there are n number of elements, and out of these n number of elements, we have to select all the members. That means all n number of elements. So what is the maximum possible number of selecting all the n number of elements out of n number of elements? Yes, there is only one possibility. So why I am taking only one possibility? Because here the order doesn't matter. We have to select the n number of persons out of the total n number of persons only once. Clear? So that is why n is equal to 1 and n is equal to 1 and nc1 is equal to n. So this is a shortcut method or simplified equation formula in order to solve questions within seconds. Clear? Okay, having said the basic idea of what actually the permutation combination is, let me explain the idea by taking two simple examples. Okay, fine. Let me say there are 5 persons. Let me take there are 5 number of persons. Fine. And there are 5 positions are there in order to occupy these 5 number of persons. Clear? Okay. I have to occupy these 5 number of persons in these 5 positions. What would be the maximum? What will be the maximum number of arrangements of these 5 number of persons in these 5 positions? Let us look. Let me take this particular position. In this position, I can arrange the person 1 or person 2 or person 3 or person 4 or person 5. Am I right? Yes. In this particular position, I can select any of these 5 members. I can choose 1 or 2 or 3 or 4 or 5. Yes. So in the second position, I have already choose one person out of these 5. So one person is already occupied there. So remaining I have only 4 persons. If I take first person here, I have the remaining these 4, 2, 3, 4, 5. If I choose the second person, the remaining persons are 1, 3, 4, 5. If I choose third person, the remaining are 1, 2, 4, 5. Clear? Okay. If I choose, I have already choose one person for this position. So remaining number of persons are 4. So the remaining number of persons are 4 here. In this position, the remaining number of positions are 3. The remaining number of persons are 3. Here the remaining number of persons are 2. Here the remaining number of person is 1. Clear? Okay. So it implies that I can choose any of this person for here. Other than him, the remaining 4, I can choose any of that 4 person here. In this position, I can choose any of these 3 persons here. In this position, I can choose any of the 2 positions here. The remaining person will be chosen for this position. Clear? So the total number of possible arrangements are 5 into 4 into 3 into 2 into 1. Clear? What actually the 5 into 4 into 3 into 2 into 1? It is 5 factorial. It is 5 factorial. So all the 5 persons can be arranged in this position or in the 5 places in 5 factorial ways, that is 120 ways. So there is 120 ways these 5 persons can be arranged in this 5 position. So total there are 5 factorial ways are possible, 120 ways are possible. Clear? So this is the idea of the simple arrangement of persons, or simple arrangement of an object or a set of elements. Clear? Okay. So let me take, there are 3 persons, 1, 2 and 3. There are 3 persons, 1, 2 and 3. And there are 5 positions are there. These are the 5 positions. Clear? Okay. And I have to choose these 3 persons for these 5 positions. These person can be arranged in any of the 3 positions, right? Okay. So this first person can be arranged or selected for this position, can be selected for this position, for this position, for this position, and also for this position. So this first person can be selected or chosen for any of the 5 position. Clear? So there is a 5 possibilities are there. So there is a possibility of 5 ways. Clear? Okay. The second person, if first person is occupied in any of these 5 position, the second person can be chosen for example, if the first person is chosen for this position, then second person can be chosen for this position, this position, this position and this position. So 4 possible ways are there for arranging the second person in any of these positions. Clear? Okay. For third person, suppose the second person is occupied here. So the third person can be selected for this position and also for this position. So there is 3 possible ways of arranging this third position. So totally the maximum possible number of chosen is 5 into 4 is 20, 20 into 3 is 30. Clear? Okay. Let me explain that the 5 into 4 into 3, if it can be represented in a factorial, what is remaining? Into 2 into 1, right? So that I can write this as 5 factorial. But this 2 into 1 is absent here. So I have to divide this 1 into 2 here. So that the value still is 5 into 4 into 3. Okay. So let me assume that there is a 1 into 2 is here. So that it becomes 5 factorial, but actually the 1 into 2 is not here, so that I have to divide the value here. That is why I written 1 into 2 at the denominator. So 5 factorial divided by 1 into 2. Okay. See, what is actually 1 into 2? The 1 into 2 is 5 factorial divided by 2 factorial. 5 factorial divided by 2 factorial. What actually the 5 factorial divided by 2 factorial? 5 factorial divided by 2 factorial can be written as 5 factorial divided by 5 minus 3 factorial. Why I written 3 here? Because there are 3 possible number of 3 number of persons, or 3 number of R. The value of R here is 3. There are 3 number of persons are selected, chosen for 5 relative positions. Am I right? Yes. The 5 is the number of position and 3 is the number of persons selected for the position. So 5 factorial divided by 5 minus 3 factorial. Clear? So this can be written as 5 is the total number of places. For this total number of places, I have chosen R number of persons and I have written n factorial divided by n minus R factorial. That is what the expression which we have discussed in the previous slide, that NPR is equal to n factorial divided by n minus R factorial. So why I have derived this equation by using an example, that if a question comes like this, you will get to know that okay, these have to be done by using the equation, by using the concept of permutation, by using the formula NPR is equal to n factorial divided by n minus R factorial. That is why I have solved this, or that is why I made this equation, or I resolved this equation from a example. Clear? So NPR is equal to n factorial divided by n minus r factorial. Clear? So this is an important one. So do understand the idea of NPR or permutation. Clear? Okay. So here there are 5 positions are there and we are choosing 3 persons. So the value of n is 5, the value of r is 3. Clear? So 5PR will be the maximum possible arrangements. Clear? Okay. If there are, let me say, if there are 5 number of persons, for example, if there are 5 number of persons and 5 number of position, what will be the maximum possible arrangements will be? Yes, definitely. If there are 5 number of persons, the value of r is 5 and 5 number of position, the value of n is 5. What actually the value of 5p5? It is equal to 5 factorial divided by 5 minus 5 is 0 factorial. 0 factorial is 1. So the answer will be 5 factorial. The 0 factorial is 1. So the answer will be 5 factorial, which we have done just earlier, which we have done just before. Clear? Okay. So 5p5 is equal to 5 factorial. This comes in the case where there are 5 number of, the value of n and r are same. When the value of n and r are same, we can simply follow the factorial, that is n factorial. Clear? Okay. So this idea can be used for the upcoming questions which I have asked in the previous years. So the first question, let's start with the first question. How many words with or without meaning can be formed by using all the letters of the word Delhi, so that each word has to start with D and end with I? Fine. So we have to arrange the letters of the word Delhi, but the condition is every arrangement must start with D and end with I. So these positions are fixed. The first and last positions are fixed, right? So we have to bother about just the 3 position in between them. That is, the remaining 3 letters E, L, H can be arranged or have to be arranged in these 3 positions. So reminder what I have said, if there are 5 number of persons and 5 positions, they can be arranged in how many ways? N factorial ways. Similarly, here there are 3 number of elements E, L, H and 3 positions are here. So these 3 numbers or 3 letters can be arranged in these 3 positions in how many ways? N factorial, that is 3 factorial. So 3 factorial is equal to what? 3 into 2, 3 into 2 is 6. So the number of possible ways of arranging the letters of the word Delhi, provided the first letter is D and last letter is I. So number of possible arrangements are 6. So the answer for this question is option D, 6. Clear? Simple question. So next question. How many different sums can be formed with denominations 50, 100, 200, 500 and 2000, taking at least 3 denominations at a time? Taking at least 3 denominations at a time. So there are 5 number of elements, total there are 5 number of elements, 50, 100, 200, 300, 50, 100, 200, 500 and 2000. So there are total 5 number of elements. Out of this 5 number of elements or 5 number of denominations, we have to choose at least 3. We have to choose at least 3, which means we have to choose 3, we can choose 4 and we can choose 5, at least 3 denominations. So out of the 5 denomination, we have to choose at least 3, so that we can choose also out of the 5 denomination we can choose 4, and out of the 5 denomination we can choose all the 5, at least 3, which means minimum we have to choose 3, maximum we have to choose all the elements. Clear? So we are actually selecting R number of elements out of the total N number of elements. So the case of selection implies combination. So 5C3, 5C4 and 5C5. Clear? Okay. So 5C3 plus 5C4 plus 5C5 will be the total number of possible selections total number of possible selecting at least 3 denomination out of the all 5 denominations. Clear? So we have to find the value. 5C3 will be, see, 5C3 can be find in quick manner, like 5C3 can be written as 5 into 4 into 3 divided by 1 into 2 into 3. So this is an easy formula. So 5 into 4 into 3 can be written as 5C3 can be written as 5 into 4 into 3. Why 3 elements? Because the value of R is 3. So take 5 elements here, take 3 elements here, 5 into 4 into 3 divided by denominator, write as 1 into 2 into 3. Similarly, 5C4 can be written as, here contain 4 elements, so 5 into 4 into 3 into 2 divided by, in denominator we have to write 4 elements starting from 1, so 1 into 2 into 3 into 4 plus 5C5, NCN is equal to what? The value of 1. So 5C3 is written as, here contain 3 elements, so 5 into 4 into 3 denominator divided by 1 into 3, 2 into 3, take 3 elements starting from 1, 1 into 2 into 3. 5C4 is written as 4 elements, 5 into 4 into 3 into 2 divided by, in denominator, take 4 elements starting from 1, 1 into 2 into 3 into 4, clear? NCN is equal to 1, so that 5C5 is equal to 1. So 2 and 4 cancel, 3 cancel, 5 into 2 it is 10, 10 plus 2 into 2, 3, 4 will cancel each other, the value will be 5 plus 1. So 10 plus 5 plus 1, the answer is 16, which means there are 16 possible combinations if we select at least 3 combinations, if we select at least 3 denomination out of the total 5 denomination. So the answer for this question is option A, 16. Clear? Okay, moving to next question. There are 4 horizontal and 4 vertical lines parallel and equidistant to one another on a board. 4 horizontal and 4 vertical lines. What is the maximum number of rectangles and squares that can be formed? Okay, so let me take, there are 4 number of horizontal lines, 4 number of vertical lines. Clear? Okay, so 4 number of horizontal lines are there, 4 number of vertical lines are there. Here the number is 4, here also the number is 4. And we have to form rectangles. We have to form rectangles and squares out of these 4. So we have to form the maximum number of rectangles and squares out of these 4 number of horizontal lines and 4 number of vertical lines. Okay. In order to form a rectangle or square, we have to choose 2 horizontal lines from here and 2 vertical lines from here, so that a rectangle contains 4 sides, 2 horizontal lines, 2 vertical lines, and a square also contains 4 sides, 2 vertical lines and 2 horizontal lines. So out of these 4 horizontal and 4 vertical lines, we have to select 2 horizontal lines and 2 vertical lines, any of the 2 horizontal lines and any of the 2 vertical lines, in order to form a square or rectangle, which means out of the 4 horizontal lines, we have to choose what? 2 horizontal lines, right? Out of the 4 vertical lines, we have to choose 2 vertical lines, so 4C2 and 4C2. So the maximum number of possible arrangements is 4C2 into 4C2, which is equal to 4C2 is equal to 4 into 3 divided by 1 into 2 into 4C2 is 4 into 3 divided by 1 into 2. So 2 to 4, the answer is 3 into 3 is 9, 9 times 4 is 36. So the answer for this question is option C, 36. Clear? So I am taking 2 lines out of this 4, taking 2 lines out of this 4. So at a time I am taking 2 lines out of the 4 horizontal lines and 2 vertical lines out of the 4 horizontal lines. So the total number of selections will be 4C2 into 4C2. 4C2 into 4C2. Clear? Okay, fine. So that answer for this question is option 36, option C, 36. Next question. The question which I asked in last year 2021, using 2, 2, 3, 3, 3 as digits, how many distinct numbers greater than 3000 can be formed? So the numbers greater than 30,000. Okay, so we have to form numbers greater than 30,000. A number greater than 30,000 implies that the number at the position of 10,000 unit place, 10th place, 100,000, 10th place must be 3. Out of these 5 numbers in the sense 2 2s and 3 3s are there. Out of these numbers, the number at the 10,000th place of 10,000 must be 3 and cannot be 2. If it is 2, then the number cannot be more than 30,000. So the number must be definitely 3. So out of the 3 3s, 1 3 is occupied here. Clear? So remaining 2 3s and 2 2s are there. Remaining 2 3s and 2 2s are there. So these 2 2s and 2 3s have to be arranged in the 4 positions. Am I right? Yes. See, these 2 numbers, these 2 2s and 2 3s, totally there are 4 numbers. Clear? Okay. So these 4 numbers can be arranged in how many ways? Yes, exactly. Total 4 numbers and 4 positions are there. So the possible number of arrangements will be 4 factorial. So these 4 numbers and 2 2s and 2 3s, total there are 4 numbers. These 4 numbers can be arranged in 4 factorial ways. That is what? It's 24. And the game is not over. See, if I am arranging 2 2 3 3, if I am arranging 2 2 and 3 3, and this 2 is replaced here, in the next arrangement I am replacing this 2 here and this 2 here. Also I am replacing this 3 here and this 3 here. Does it make any change? No, because these 2 and both these 2's are same, both these 3's are same. Clear? We cannot distinguish this 2 by this 2. Clear? So if I am changing the same numbers in their with their positions, for example, if I am taking 2 here and 2 here, it doesn't make any change. The arrangement remains same. So it cannot be counted as another arrangement because both remains the same. Clear? So in such cases, we have already found the total number of arrangements. This 24 includes the first case and the case in which these 2's and 3's are replaced. This 24 contains a total number of arrangements of the 4 elements. Unfortunately, the 4 elements contain 2 similar pairs, 2 2's and 2 3's, so that we have to consider the similar arrangements which are repeating. That is, in the first case the arrangement was like this, and I have changed the 2's and 3's with their position and it becomes the same, but this is also included in this 24. So we have to subtract, or we have to delete the second arrangements or the arrangement which comes like this. Clear? Replacing the same elements. So we have to delete that. To do so, what we are doing is we got the total number of arrangements which are 24, and dividing, it is a pair and it is also a pair. So these two numbers can be arranged or changed in how many ways? 2 factorial. And these 2 3's can be arranged in 2 factorial, because 2 factorial in the sense, in the first case the arrangement was 2 2 and 3 3. Second case the arrangement is 2 2 3 3, when after changing these two swapping these 2 2's and swapping these 2 3's. Clear? So how many possible arrangements are possible? In case of 2's, there are 2 ways. In case of 3, there are another 2 ways. So we have to deduct that possible arrangements here. So dividing that possible arrangements with the total number of possible arrangements will be the final answer or actual answer. So 24 divided by 2 into 2, which means the answer is 6. 4, 24 divided by 4 is 6. So there are 6 possible number of arranging the these 4 elements in this 4 position, so that we get a number greater than 30,000. Is it clear? Yes. Moving to next question, a similar kind of question, but have to be think in a different way, because here the game is in a different style. Okay, let us look what actually the case is. The question says, if 2 boys and 2 girls are to be arranged in a row so that the girls are not next to each other, how many possible arrangements are there? Okay, there are 2 boys and 2 girls arranged in a row so that the girls are not next to each other. The girls are not next to each other. See, there are 4 persons and 4 positions. Clear? See, there are 2 boys, boy 1, boy 2, and girl 1, girl 2. Clear? So there are 4 persons are there and 4 positions are there. The question is asked to find the number of possible arrangement in which no girls are not next to each other. Girls are not next to each other. If such a case comes in a question, what you have to do is, you have to find first the total possible number of arrangements. Then subtracting, I am repeating, then subtracting the number of possible arrangement in which the girls are sit next to each other, so that you will get the number of possible arrangement in which the girls do not sit next to each other. The total number of arrangements, let me say, total number of arrangements will be equal to arrangements where girls sit next to each other plus arrangements where girls do not sit next to each other. So the total number of possible arrangements will be the sum of arrangements where girls sit next to each other plus arrangements where girls do not sit next to each other. So if you have to find the arrangements where girls do not sit next to each other, is subtracting the total number of arrangements and subtracting the arrangements where girls sit next to each other from the total number of arrangements, which is quite easy. Clear? Okay. By adopting this idea, we can solve the questions. Clear? So 4 numbers are there. So 4 persons are there. So the total number of arrangements. So the total number of arrangements will be equal to 4 persons, 4 positions are there. So the total number of arrangements will be 4 factorial, that is 4 into 3 into 2, 4 into 3 is 12, 12 times 2 is 24, the answer is 24. Now what we have to find, the number of arrangements where girls sit next to each other. The number of possible arrangements where girls sit next to each other. Let's look. See, if girls sit next to each other, let me take, see, the girls sit next to each other. Okay. And these 2 girls can sit here, here, and here. Sitting next to each other implies they are in the first and second position, or second and third position, or third and fourth position. Clear? Okay. If they are sitting each other and the other 2 boys, let me take the B1 is here, B2 is here. So they are now considered as a single set. The 2 girls which are sit next to each other now is taken as a single set. This is a single set, this is a single set, and this is a single set. Now, how many possible ways are there in which, so this single set, and there is a let me assume that there is a single person. These two girls are sitting next to each other. So that is the entire system. The two girls and their relative seats is taken as a single set. Are you got it? Yes. Okay. So these two girls are sitting next to each other is taken as a single set. So which means there are three relative position. In the first position, girl 1 and girl 2 sit next to each other, sit together. B1 is here, B2 is here. So these three elements and their three relative positions, they can be arranged in 3 factorial ways. Are you got it? Yes. Now, in the last case, to find the numbers greater than 30,000, what we have done actually is, so these three elements can be arranged in the 3 position in 3 factorial ways, right? One more thing, even if the first position, even if the two girls are in their first position, clear, but these two girls can be swap each other. That is, in the next case, girl 2 can sit here, girl 1 can sit here. So these two sets can be arranged in another ways also. Even if the boy 1 and boy 2 sit in their same position, in the next case, the girl 2 can sit first here, girl 1 can first sit in the second. So within this pair, another 2 factorial arrangement is possible. Are you got it? Yes, because see, in the first case, the arrangement can be G1, G2, B1 and B2. In the second case, the arrangement can be G1, G2, G1, B1 and B2. So in a particular arrangement, the girls can be arranged in 2 ways. This is the first ways, this is the second ways. So the number of arrangements in which the girls are sit together will be 3 factorial into 2 factorial. So 3 factorial into 2 factorial is 3 into 2 into 2, that is 3 into 2 is 6, 6 into 2 is 12. So the number of possible arrangements in which the girls sit next to each other is 12. So that the answer for the question here, that the number of possible arrangements that the girls are not next to each other is equal to total number of arrangements minus number of arrangements where the girls sit next to each other, that is 12. 24 minus 12 is equal to 12. The answer for this question is option C, 12. Clear? Okay. Moving to next question. A student has to opt for 2 subjects out of 5 subjects for a course, namely commerce, economics, statistics, mathematics 1 and mathematics 2. Mathematics 2 can be offered only if mathematics 1 is also opted. The number of different combinations of the 2 subjects which can be opted is, okay, fine. See, listen, there are 5 subjects: commerce, economics, statistics, maths 1 and maths 2. Clear? Okay. But there is a condition that maths 2 can be opted only if maths 1 is also opted, which means maths 2 and maths 1 comes together, which means that if there is a maths 1, then only the maths 2 will be allotted. But maths 1 can be associated with other subjects also. For example, maths 1 can be taken along with economics. But if only there is a maths 1, the maths 2 will be allotted. So both maths papers can be taken together. Maths 2 can be taken only with the maths 1. But maths 1 can associate with maths 2 and other subject also. Clear? Okay. So maths 2 can be selected along with maths 1. So this is a single possible combination as far as the maths 2 is concerned. Only one possible combination, that is, if there is a maths 1 only, maths 2 can be allotted. So maths 2 will come only with a maths 1. Clear? So that's the only possible combination in case of maths 2. The remaining, there are 4 subjects: commerce, economics, statistics and maths 1. So, clear? Okay. The number of different combination, okay, a student has to opt for 2 subjects out of the 5 subjects. So clear. Now the remaining subjects are 4 because max 2 can be possible in a single way, that is along with max 1. Max 2 cannot taken along with another subjects, any other subjects. So this is a single case which is taken as, reserved. So the remaining possible, the remaining number of subjects are commerce, economics, statistics and max, that is 4 number of subjects. Out of the 4 number of subjects, we have to select how many subjects? 2 subjects. Clear? So the 4C2 will be 4 into 3 divided by 1 into 2. 3 into 2 it's 6. So there are 6 possible ways in which a student can choose 2 subjects out of the 4 subjects, right? Also max 2 can be selected along with max 1, that is a single way. So total number of possible arrangements will be 6 plus 1, that is 7. Let us look whether there is an option. Yes, there is an option. Option C and is 7. Answer for this question is option C, 7. Simple question. Okay, fine. Moving to next one. There are 5 tasks and 5 persons. There are 5 tasks and 5 persons. Task 1 cannot be assigned to either person 1 or person 2. Okay, let's take the task 1, task 2, task 3, task 4, task 5. And there are 5 persons P1, P2, P3, P4 and P5, right? Okay. The conditions are task 1 cannot be assigned to either person 2 or person 3. So task 1 cannot be assigned to either person 1 or person 2. Similarly, task 2 must be assigned to either person 3 or person 4. So task 3 must be assigned to either person 3 or person 4. Let me rewrite this as task 1 cannot be assigned to either person 1 or person 2, which means that task 1 can be assigned to either person 3 or person 4 or person 5. So this is the case. And the remaining 3 persons can be assigned to any subjects or any task. So this is a case, and we have to find the maximum possible number of ways in which the assignment can be given. For this, we have to consider 2 cases. The first is case 1. Case 1 implies where the task 2 is assigned to T2 is assigned to person 3. See, if task 2 is assigned to person 3, then task 1 can be assigned in how many ways? If task 2 is assigned to person 3, so person 3 is also occupied. So this is not possible. So 2 possible ways in which task 2 can be assigned. Task 2 can be assigned to either person 4 or person 5. So task 1 can be assigned in 2 ways. Clear? Task 2 was also assigned, that is in one way. Then task 3 can be assigned. Task 3 can be assigned to any person. Clear? Okay. But 2 persons are also occupied, remaining 3 persons. So task 3 can be assigned to 3 persons. Task 4 can be assigned, remaining how many persons? 2 persons are there. So the task 4 can be assigned to 2 persons, that is 2 ways. And the remaining task 1, only 1 person is left. So task 5 can be assigned in 1 way. Clear? Okay. So these are different possible combinations in which these tasks can be assigned if task 2 is assigned to person 3. So the total number of arrangements will be equal to 1 into 2 into 3 into 2 into 1. 3 into 2 is 6, 6 times 2 is 12. So the total number of arrangements if task 2 is assigned to person 3 is 12. Now we have to consider the case 2. Case 2. What is a case 2? The case 2 implies task 2 is assigned to person 3. Task 2 is assigned to person 4. Person 4. If task 2 is assigned to person 4, task 1 can be assigned to. Already person 4 is occupied. So but person 3 and person 5 remains for task 1. So task 1 can assigned in two ways. Task 3 can assigned in, as in the similar last case or the case 1, task 3 can be assigned in 3 ways. Task 4 can be assigned in 2 ways because only 2 persons are left, and task 5 can be assigned in only 1 way. So here also the total number of arrangements will be 1 into 2 into 3 into 2 into 1. 1 into 2 into 3 into 2 into 1, it is 12. So here the total number of arrangements in the case 2 is 12. In case 1 the total number of arrangement is 12. So in total together the total number of arrangements will be 12 plus 12, that is 24. So the answer for this question is option C, 24. Clear? In a society, it is customary for friends of the same sex to hug and for friends of the opposite sex to shake hands when they meet. A group of friends met in a party and there were 24 handshakes. Which one of the following numbers indicate the possible number of hugs? Okay. So there are males and females. The members of same sex, that's male hug to each other and female hug to each other, and the male handshake with females and females handshake with male. So this is a customary practice in a society. So if the members of opposite genders handshake with each other and there are total 24 handshakes are there. Let me take the number of male members are X and the number of female members are Y. See, if there are total 24 handshakes done by members of opposite sex each other, it implies that X into Y is equal to 24. Am I right? For example, if there is one male member, one male and 2 female members, this one male member will handshake with this female member and also with this female member. So total there are 2 handshakes. How we got 2 handshakes? 1 into 2, simple. So let me take, if there are 2 male members and this male member will handshake with this female member and also with this female member. So totally there will be 4 handshakes. How we got? 2 into 2 is 4. So which means the number of male members into number of female members will be equal to the number of handshake done between them, done among them. Clear? So X into Y is 24. Now we have to find the number of possible hugs. Okay. So what we have to find? A hug is given by a male member to a male member and a female member to a female member. So out of the total X number of persons, 2 persons hug each other, so that the expression will be XC2. And out of the Y members, 2 members hug each other, and so the total number of hug will be find out, which is a YC2. And we have to find this product value XC2 into YC2 that we have to obtain, which is given in this in any of the one of these 4 options. So okay. So we have to find what actually the value of XC2 and YC2 is. Before that, let me assume different value for X and Y. It is given that XY is equal to 24. Though X can have values of 1, then Y can have value of 24. X is equal to 2, Y is equal to 12. X is equal to 3, Y is equal to 8, X is equal to 4, Y is equal to 6, and it goes on. X is equal to 6, Y is equal to 3. The value will be changed. So in first case, x is equal to 1, y is equal to 24. Let me check the value xc2 into yc2 can be found in any of these options. First case, xc2 into yc2. xc2 implies 1c2 into 24c2. Let me say the value of n is here 1 and the value of r is 2. Can we select two persons out of one person? No, it is not possible. We cannot select two persons out of one person, no. So this combination is not possible at all. We can discard this at the first instance. In the second case, the value of x is 2, so 2c2 into y is 12c2. So nc1 is equal to n into 12c2 is 12 into 11 divided by 1 into 2, 12 is 6, 11 6 is 66. Is there an answer? No, there is no such an answer. So this case cannot be correct, so it can also be discarded. In the third case, 3c2 into 8c2, which means 3 into 2 divided by 1 into 2 into 8 into 7 divided by 1 into 2. 2 will cancel each other. 2 8 4 7 4 28. 28 times 3. No, such an answer is not here. So this option cannot be correct. So the remaining one is x is equal to 4 and y is equal to 6. So it gives 4c2 into 6c2. 4c2 is equal to 4 into 3 divided by 1 into 2 into 6c2 is 6 into 5 divided by 1 into 2. Let's check. 2, 2, 4. Yes. So the value of x into y is 24. What we have to calculate, see, for every hug there will be two persons of same gender or same sex. So out of the total x number of persons, two numbers will engage in a hug. So the value will be xc2. And out of the total y number of female, two members engage in hug. So the total possibilities are yc2. And we have to add that together so that we can find the total number of possible hug between members of same sex. So what we have to actually find the value of xc2 plus yc2, but we don't have the values of x and y, but we can get the values of x and y from this idea. Okay, so the value of x and y is 24. The value of x and y is 24. The value of x and y can be different. For example, to have x into y is 24, x can have the value of 2 and y can have the value of 24, and x can have the value of 2 and y can have the value of 12, x can have the value of 3, y can have the value of 8, x can have the value of 4 and y can have the value of 6, and so on. The value will be changed, x to y and y to x. Okay, so let us take each case and find whether xc2 plus yc2 can have any of these four values. Okay, let's check. The first case is x is equal to 1 and y is equal to 24. The expression will be 1c2 plus 24c2. Take this case. 1c2 implies that I am taking two persons out of a set of one person. Is it possible? No, we cannot choose two persons out of one person, which is not possible. So this is not correct. Let's move to the second case. 2c2 into 12c2. 2c2 into 12c2. 2c2 is equal to 2c2 plus 12c2. 2c2 is equal to 1 plus 12c2 is equal to 12 into 11 divided by 1 into 2. 11 into 6 is 66, 66 plus 1 is 67, no, not such an answer. So this is not correct, okay. Third case, x is equal to 3, y is equal to 8. So expression can be 3c2 plus 8c2. 3c2 is equal to 3 into 2 divided by 1 into 2 plus 8c2 is equal to 8 into 7 divided by 1 into 2. 2 cancel each other. 2 4 7 4 28. 28 plus 3. It's 31. No, not such an answer. So this is not a probable answer. So the last and final option is 4 and 6. So 4c2 plus 6c2. 4c2 is equal to 4 into 3 divided by 1 into 2 plus 6 into 5 divided by 1 into 2. So 2 2 4 can, sorry, 2 and 4 will cancel each other, 2 will be here, 2 and 6 will cancel it, 3 will be here, 3 into 2 is 6, 5 into 2 is 15, 15 plus 6, 21. Whether there is an answer? Yes, option C is 21. So the answer for this question is option C, 21. The question is bit difficult. I recommend to those students who are not that much proficient in solving maths to leave this question in order to save your time. Okay, it takes a little bit logic and it takes a lot of time, so it's not a problem if you skip this question. Okay, however, this is a way of solving this kind of question. Clear? Okay, moving to next question. A bag contains 20 balls. 8 balls are green. A bag total contains 20 balls. Out of this 20, 8 are green, 7 are white, and 5 are red. What is the minimum number of balls that must be picked up from the bag blindfolded without replacing any of it to be assured of picking at least one ball of each color? The bag contains total 20 balls. There are 8 balls are green, 7 are white, and 5 are red. And one person blindfolded has to take a certain minimum number of balls so that it must contain at least one ball of each color. So the minimum possible arrangement, let me take. If I am taking 8 balls, there is a probability or possibility that all the 8 are green, so that it doesn't contain a ball of white and red. Clear? Okay. If I am taking 12 balls, there is a probability and possibility that all the 12 balls are white and red. So 7 plus 5 is 12. Clear? It may not contain a ball of green. If I am taking 15 balls, there is a chance that all the 15 balls are of white and green. 8 plus 7 is 15. But if I am taking 16 balls, even if all the 15 balls are, the 15 balls are of white and green, the next ball will be red. Is it clear? Yes. So the minimum possible number of selection is 16, so that it contains the balls of all the different colors. Clear? Okay, the answer for this question is option B, 16. Next question. There are 24 equally spaced points lying on a circumference on a circle. So this is a circle and it contains 24 equally spaced points. Okay, so there are total 24 equally spaced points on a circumference of a circle. What is the maximum number of equilateral triangles that can be drawn by taking a set of 3 points as the vertices? They have asked about the equilateral triangles. Equilateral triangle in the sense all the sides are equal in dimension. The length of all the sides are equal. See, if I am taking this point, then I have to take 2 points so that the dimension, 2 other points, so that the length of the lines are same. Okay. See, I am taking every 8th point. This is the first point and this is the 8th point. From here, this is the 8th point. From here, this is the 8th point. So that we get a equilateral triangle. But I cannot choose this point along with this point. If I am drawing like this, it will not be an equilateral triangle, because here the distance between the points is 1, 2, 3, 4, 5, 6. 6 points are in between them. But here 1, 2, 3, 4, 5, 6, 7, 8. 8 points are in between them. And here also 1, 2, 3, 4, 5, 6, 7. 7 points are in between them. So if I am taking A, B, C triangle, it will not be an equilateral one because the number of points between the three vertices are different. But if I am taking ACD as an equilateral triangle, the distance between the vertices or the number of points between the vertices along the perimeter, along the circumference of the circle remains same. Here it contains 8 points, 1, 2, 3, 4, 5, 6, 7. Here also 1, 2, 3, 4, 5, 6, 7. Sorry, it contains total 7 points. Here also it contains total 7 points. Here also 1, 2, 3, 4, 5, 6, 7 contains 7 points. So if I am taking A, D, Z at the as the three vertices, it will give an equilateral triangle. So that why? Because the number of points in between the three vertices along the circumference of the circle remains same, which is 7. Okay, so this is already selected, and I cannot choose the point A with any other points other than D and C. So these 3 points are already selected, which is not possible for any other case. Similarly, this point can be selected along with this point, which is P, and this is Q, and this is R. Okay, so the triangle will be clear. So this is another case, and the next one, this point, this. Similarly, how many different possible combinations are possible? 1, 2, 3, 4, 5, 6, 7, and last 8. Okay, so 1, how many possible combinations? 1, 2, 3, 4, 5, 6, 7, and 8, because this point comes along with this point. Clear? So 1, 2, 3, 4, 5, 6, 7, 8 possible combinations are there. So the answer for this question is option C, 8. Clear? Okay, the last question in the series. There are 6 persons arranged in a row. Another person has to shake hands with the 3 of them, so that he should not shake hands with the 2 consecutive persons. So there are 6 persons, P1, P2, P3, P4, P5, P6. Okay, and extra other person who want to shake hands with the 3 of the persons, so that he should not shake hands with the 2 consecutive persons. Okay, let us take different cases. In the first case, he is shaking hands with the P1, so that he cannot shake hand with the P2, but possible with the P3. Not possible with the P4, but with the P5. In the second case, starting with P1, P1 is possible, P3 is possible, but P4 is not possible, P5 is already selected, P6 is possible. Third case, P1. P1 is possible, P2 is not possible, P3 is already selected. Let us take the case of P4. If P4 is selected, then P5 is not possible, but P6 is possible. In the fourth case, no other possibilities starting with P1. Now let's move to P2. If P2 is selected, P3 is not possible, but P4 is possible, then P5 is not possible, P6 is possible. If P2 is selected, the next case, fifth case, P2 is selected, P3 is not possible, P4 is already selected, P5 is possible, but P6 is not possible, so this is not a possible case. So the maximum possible number of arrangements, shaking 3, if P3 is selected, then P3, P5, no other number, P1 is possible, that is what is given, P1, P3, P5. So there is no further possible combinations, are there, so the maximum possible number of combinations is option 4, which is option B. So that's the end of the session. We have covered around 15 questions from the topic permutation and combination. I agree the topic may be a bit dry and confusing to those students who are not that proficient in solely maths. So what I have to suggest is understand the idea of permutation combination. The idea is a bit simple. If you got the idea, then you can solve all the questions from the particular topic. If the question is very simple, you should not leave the question. If the question is a bit lengthy or confusing, then it is better to leave that question. Anyway, practice this question. There is a chance that the certain question, simple question can come from this particular topic. So do practice the questions from the topic and practice more questions from the topic. We will be back with another topic in the next session. Till then, have a nice day. Thank you.
Amrita IAS Academy.